All right. Well, it's my pleasure to start off the closing keynote by introducing Chris Kemp. So I've got here a note that when Chris left his position as CTO for IT at NASA, which raises the question, why on earth would you leave a position like that? But he answered it as, I'm leaving the place I dreamed of working as a kid to find a garage in Palo Alto to do what I love. And I think that's tremendous, and a lesson that perhaps we can all learn in terms of seeking positions where you can do what you love. So I'm really excited to hear what he has to say. At NASA, Chris co-founded the OpenStack project, which is very, very important to the work that Cyber is doing. So again, lots of connections, and started the NASA Cloud Computing Project, which was a significant turning point for open source and cloud computing. He's helped build partnerships with Google and Microsoft, and we were chatting a moment ago about some of the folks that we've come across from Google, from NASA Ames, and bumping into many of them. So truly is a small community, but for those of us who haven't had the opportunity to hear from Chris before, we're going to start out with a quick video, and then Chris is going to give us the keynote talk.
Well, to create a new standard, it takes something that's not just a little bit different. It takes something that's really new.
I think one of the things that really separates us from the high primates is that we're tool builders. And that's what a computer is to me. It's the most remarkable tool that we've ever come up with. It's the equivalent of a bicycle for our minds.
Cloud can be a place where we can discover beautiful things. Thoreau said you're rich in proportion to what you can afford to let alone. You know, there's things we don't need to know. It's other people's job to handle them.
Ultimately, we're building out the equivalent of a global brain, you know, where all of the computers in the world, all the networks in the world are connected.
We take the grid, we take electricity for granted. We take the infrastructure that it should just be there, and so should computing. We want lots of innovation in the cloud, and open source and open standards give us that possibility.
Technology-free markets tend to produce more innovation because people can do things that everybody else thinks are crazy that turn out not to be crazy at all.
10, 9, 8, ignition sequence start. 5, 4, 3, 2, 1, 0. Launch commit, liftoff, and we have liftoff.
60 years ago, Thomas Watson of IBM is reported to have said that he saw a need for no more than 5 computers worldwide. A dozen years ago, people said that only a few companies would need Google-scale computing infrastructure. We now know that they were all wrong.
I believe that democratizing large-scale computing could lead to the kind of game-changing advances in physics, chemistry, material sciences, and other fields.
History is a wave that moves through time slightly faster than we do, and we feel like we're up to date with technology, and then something wakes us up.
So thank you all for having me today, close this summit out. That's why I left NASA. I was inspired by the potential of the technology that we had developed to change the world. And we look back over the last 25 years of computing, and you see things that were open, standards, protocols, infrastructure. The internet is a great example of the foundation for an incredible amount of innovation over the past 20, 25 years. And when you look at the things that were closed, storage technology, computing architectures, there wasn't a lot of innovation. And so I see a unique turning point right now in history where if open standards and projects like OpenStack prevail, it will create an incredible opportunity for innovation. Innovation in academia, innovation in sciences, innovation in companies coming out of Silicon Valley, because it creates the possibility for new technology to be inserted into major projects that they'll never have the opportunity to be inserted into if you've acquired proprietary closed technology that doesn't support interoperability, workload portability. And so what inspired me at NASA was this picture. This was the year we discovered Earth. This was December 24th, 1968. Astronaut Bill Enders aboard the Apollo 8 spacecraft wasn't actually supposed to take this picture, but he took out his Hasselblad camera and he snapped this picture. This was the first picture of the Earth from space. NASA didn't really recognize the importance of this picture, but this picture became the turning point for the environmental movement. And really, in the 1960s, it allowed us to kind of look at our planet from a whole new perspective. And this is the kind of thing that inspired me at NASA to go out and figure out how all the other incredible content that we had could change the world. And so, fortunately, we had a few other companies out in Silicon Valley that kind of shared this vision, and we're working on technologies that it wasn't clear how they'd profit from the technologies, but they knew that if they were to pull information and data together, it would create value. Being from NASA, I couldn't just stop, at Google, but we had to reach out to all companies. So we formed partnerships with Google and Microsoft, and we created platforms like Google Mars and Google Moon. And as we created these platforms, that's the Victoria Crater site in 3D that you can see if you click Mars and Google Earth. You weren't able to do this because Google didn't have this data. And there were NASA scientists and NASA systems where this data resided. JPL, you could download large images. You had access to the data. But there was a real difference in having access to a bunch of JPEGs that took an hour to download and being able to click a button in a product that had hundreds of millions of users where they could experience that data in a way that would allow them to do things as basic as look at this in a classroom and inspire kids in schools to get into science, to something as advanced as using this as a platform for data visualization. Because at NASA, we were spending a lot of money essentially replicating the functionality of products like Google Earth so that scientists could visualize data sets. When fundamentally KML was becoming an open standard and we were able to potentially embrace platforms like this without having to invent them from scratch, thus allowing us to invest more money in actual science. We reached out and we also formed a similar agreement with Microsoft, created Worldwide Telescope Mars. It's actually interesting because Microsoft was trying to differentiate themselves out of their research group as a more scientifically focused organization led by Tony Hay and others at Microsoft Research. Dan Fay and a bunch of other scientists wanted to have the highest resolution data set. And so we actually worked with Microsoft. The challenge was we didn't have a way to host this. And so this is kind of what really started to get me thinking about the kind of infrastructure we needed to invent in order to think about science in a new way. The challenge was the day we released this, there were hundreds of thousands of people that clicked on links and visited Worldwide Telescope, and NASA had to serve this up. And our systems and our infrastructure was really designed for a small number of scientists to probe deeply into data sets, not for hundreds of thousands of people to all start requesting the same images simultaneously. And so we had kind of a scale-out web problem as we started to think about using data as a data outreach platform. And so this got me thinking about how we would solve this problem. And so we put together a really small team of people, 3 or 4 people, that started to think about how we could take this data and data from dozens of additional platforms that NASA has launched over the years and are bringing back tons of data. All these platforms are bringing data back. And NASA's had a rich legacy of creating the planetary data system and data systems groups at various universities so that scientists can investigate this data. But this new era of connecting this and rendering it in ways that it was consumable to the public it was kind of challenging to these organizations because that wasn't what they built these data systems and data systems architectures to do. So as we started to think about the problem, I was given the opportunity to compete and be the CIO out at Ames Research Center, which is where NASA does a lot of its IT research, a lot of supercomputing. And so the team of people that we put together were not kind of NASA PhD rocket science type guys. These were hackers. These were people in the open source community that were trying to think about how web companies built scale-out infrastructure, how we could use commodity hardware and open source tools to create a platform for NASA. NASA spent over $2 billion a year on IT infrastructure and operations. If you look at NASA's budget, which ranges between $18 and $20 billion, that was over 10% of our annual budget. You could fund most space agencies in the world for what NASA spent on IT alone. And this was a challenge. We needed to figure out how we could do this more efficiently. The reason why we're spending so much money is the money wasn't spent in a few different places. It was spent in thousands of different places. The money trickled through NASA's budget and ended up in small labs here and small data centers there. And you really couldn't find a single place at NASA that had more than a few $1 million, with the exception of maybe one of the supercomputing centers that would, in a good year, pull in a few tens of millions. $2 billion a year, though, was being spent. So a lot of money was going to hundreds of different contracts and contractors at different sites. And so we had a vision for a shared computing infrastructure. And at the time, there were some guys that shared the vision that Amazon had and were open sourcing some technology at a UCSD. Rich Wolski and some other academics had launched a company called Eucalyptus. And so we were really excited about this, and we're one of the early adopters of Eucalyptus, and we deployed Eucalyptus in our environment. And we decided that virtualization would be the platform that we would build this new platform, web platform. And so we worked really hard with these guys. And ultimately, we built something that we called the Nebula Project. And the project was able to do basic infrastructure automation and virtualization. We started to talk about this. I was in Washington in 2009 when we first started talking about this inside the Beltway. I was still CIO at Ames. And a gentleman named Richard Shelby, who was a senator, he was at the time, I'm not sure if he still is, the chairman of the House Appropriations Committee for Science and Technology, didn't like the idea that we would increase the efficiency of IT at NASA, because he looked at IT as a jobs program in Alabama, where he was a senator. And this was really challenging. I didn't understand how an agency that spent so much money on IT wouldn't embrace technology that would empower scientists to have the infrastructure they needed, to have the ability to host data in a new way. And so this got kind of interesting. We were ordered to describe every penny spent on the project, and then my phone rang. And this means, well, now this means two things to me. It's either a telemarketer or it's the White House. Unfortunately, I answered the phone, and it was the White House. And so Vivek Kundra, who was the newly appointed CIO, was also thinking about how we can increase the efficiency of IT in the United States government, and had started to talk about cloud computing. And unfortunately, there weren't a lot of government agencies that were successfully deploying cloud technologies. And so he was looking for an example of one that was. He was looking for an example of someone who, in the government, was successfully using cloud technology to solve problems. And what happened there was he wanted to launch the federal cloud computing strategy at Ames Research Center. So to me, this meant that it was time to kind of really execute. We had a date where the White House was sending a huge landing party out at Ames, and they were going to launch the United States cloud computing strategy at our center. And so we needed to pull this stuff together and really make it solid for these guys. So we amped up efforts. We were not able to build facilities very easily, so we adopted a shipping container strategy for the infrastructure. I always believed that fixed fortifications were monuments to the stupidity of CIOs. So looking at a lot of the data center infrastructure we had, it wasn't really designed for the power densities that we were seeing in these modern high-density compute infrastructures. And so even in our supercomputing facilities, we were running into situations where we could only fill racks with equipment half full, because they'd either fall through the floor because they were disks that were too heavy, or because we just didn't have the power densities in the racks to support, or the cooling to support the infrastructure. And so shipping containers kind of allowed us to be a little bit more flexible with the placement of the infrastructure. And it turned out that, I don't have a chart on this, but NASA was one of the first nodes on ARPANET. And so a lot of network peering was happening at a facility called May West, which I happen to manage. So what we wanted to do is keep the cloud right next to the edge of the network so we could peer with a lot of the tier 1 network providers, because it was very important that we could get data out of NASA to the people that were consuming it. If this was a cloud that was designed to be kind of like an infrastructure as a service, platform service where you could consume data from NASA, we wanted to be on the edge of NASA's network, not kind of deep inside where we had to depend on a lot of networks to kind of get traffic across our internal backbone before it could get out to a gateway to the internet. A lot of stories about how a little project called Tick was getting in our way of doing that, but I'm not going to go into that right now. So Vivek came, and we had a fantastic launch of the apps.gov website and the US cloud computing strategy. And ultimately, we started operating this platform. This was a catalyst for bringing together a lot of the leaders in Silicon Valley to talk about what we needed to do in the government to make cloud computing a reality. So we were able to, that's Surinder Reddy, who at the time was the VP of cloud computing at Yahoo. It was kind of interesting to be around a table and have Sergey Brin and folks like that were kind of there because they had to be there, right? Because in order to do business with the government, there needed to be a communication established. And what we were able to do is establish that communication. So this kind of became the shield that we used to innovate. And if there's any lesson here, it's that you need executive support in any of these cloud projects. This isn't going to happen as entirely a ground-up, bottoms-up project, because really you're causing a lot of disruption to the people, the lives, the organizations, the vendor relationships that exist kind of down in the trenches. So unless you have executive support, in our case, we needed the White House and the president to support us. And as it turned out, there were some lucky little dynamics where there was a site that the president himself was very specifically concerned with, because it was one of the 3 things that Obama did as a senator before he became president that he took very seriously. There were 3 primary pieces of legislation that Barack Obama kind of really pushed and made him kind of a forefront contender for the presidency. One was the Obama Coburn Act, which was an act that talked about transparency, right? So there was a real need to become more transparent with American taxpayers on how the government spent its money. And there was an effort to do this, but once Obama installed Vivek and started to pull together his team, he wanted to really do it right. And so there was a website called usaspending.gov, which Vivek called one day and he said, I want to host this on NASA's cloud. And this was somewhat unprecedented, right? Usually the government would do a procurement and they would award a contract to some sort of vendor, but there weren't any vendors that were doing this the way that they wanted to do it. And Vivek wanted to make this right. He wanted to do it right from the infrastructure all the way up to the implementation. So he wanted the user experience. It was an experience that I was delighted with. I mean, Vivek was like an entrepreneur in Silicon Valley. We had, as he brought this site online, there were meetings on Saturdays, meetings on Sundays. The team needed to get this up and it needed to be reliable. And what was unique about this site is it provided an incredible amount of detail on how the U.S. spent $4 trillion of its budget in civilian programs. And you would literally, and you can go to the site now, it's actually still hosted at NASA, you can drill down and see how much money is spent by zip code, by contractor, by state, and all of this data is updated daily. So we're re-ingesting additional data into this site, and it's being re-denormalized, and indexes are being created. This used to happen quarterly at best. And so the kind of the visibility that this provided into how the government operated was unprecedented, and what it required in order to be affordable was the infrastructure that was serving the data to be repurposed to process the data. And so the roles of the compute infrastructure were constantly changing from being web-serving roles to being kind of analytics, data processing, data crunching roles. So at night, this thing would kind of warm up and start processing the day's data and re-rendering all the indexes. In the day, it would primarily be serving data. What we knew, though, was if this was an internal project, it ultimately would be a flash in the pan. So it was extremely important for our team to open source the work we had done. And so at about this time, an opportunity was created to come to Washington and be the CTO of the agency. This was largely a result of the work we did in cloud computing and the work that was being recognized within the government. And NASA had never had a CTO before. And the opportunity to form a new organization that was responsible for technology insertion, applied IT technology across the entire agency was pretty compelling to me. So one of the things that I needed to do is make sure that without the ability to be directly involved in the daily operations of the project, because I was going to Washington and I was becoming further removed from the actual innovation that was going on, I needed to really make sure that this project had a life outside of NASA. So I worked very hard to open source this work under a license framework that would allow it to be adopted by others. NASA had what we call a vanity license. We had the thing called NOSA, which is NASA Open Source Agreement. It was like Apache, but it wasn't. And so the challenge was if you were a company or university, you were unable to just have a blanket approval to use it. You had to talk to your lawyers, which essentially meant no one would touch it. It was radioactive. So even though it was essentially Apache 2, it wasn't. So we pioneered the first Apache 2.0 release in the history of government, and a framework for doing that for other projects, and also a framework for true open source development. And it's really difficult to release software because there's about a 15-step process where everybody needs to look at it. The lawyers need to look at it to make sure you haven't infringed on anybody's IP. The export control people have to look at it to make sure you haven't exported encryption technology. I mean, there's just this huge long list of checkboxes. And so if you think about the way a modern open source project works, you're checking in code to a public repository all the time. And so the more friction you place in that release process, the less frequently you can make contributions, and thus the less effectively you can participate in that community. So this was important. Once we knocked that out, got a call from Rackspace. And this was a company that was a distant second number 2 in the cloud computing space. Amazon was clearly the largest public cloud provider, but Rackspace was trying to compete. But they didn't want to compete on technology. They weren't a software development company. They weren't a technology company. They were a service company. And so they came to me and they said, look, Chris, the way we make money is by providing great service and not by developing and innovating technology. And we're really interested in basically taking all the stuff we've developed and open sourcing it so it can be a community project. And we're going to be good stewards of that project, but we want to basically let this stuff go and see if we can't take a run at making OpenStack the de facto standard in open source cloud computing. And I thought this was a good thing. I can't, obviously, at the time I was the CTO of NASA, so I couldn't endorse anybody. I couldn't endorse Rackspace. But I could endorse the idea of a bunch of developers contributing code to our project, right? So, and I also couldn't prevent them from doing this because we had released this under an Apache 2 license. So they frankly didn't have to even ask us for the code. They could have just taken it and forked it and gone on their merry way. But the opportunity to encourage the American public to make code contributions to this was an opportunity to reduce our costs, right? Because anything that was contributed to the project that we didn't have to pay to develop, we could then use and take advantage of. So I don't know whether that's a series of loopholes or just the framework for a new way of commercializing technology in government, but it worked. And came down to the wire. We got this thing open sourced just before OSCON, and this is in 2010. We released the OpenStack project. That's the president of Rackspace and I saying, contribute code to OpenStack and help NASA explore the solar system. And the good news is everyone did. And since then, we've had design summits. I actually was in Boston most of yesterday and yesterday evening. Difficult to get here. But we were literally turning people away. We had hundreds of people show up that couldn't register because the Design Summit was sold out. All the Design Summit sessions were standing room only. And this has been 1 year and 2 months since the project was launched. So though I don't have the stats, this could possibly be the fastest growing open source project in history. It certainly is in terms of the number of companies that have gotten behind it to support it. We have companies that traditionally compete, like Dell and HP, Intel and AMD, companies that do switches, do infrastructure, ops code Puppet, hosting providers like Internap and Equinix and SoftLayer and NTT. And this is just a small subset of companies, so if someone in the room here is represented here, I didn't get your name, sorry, but there's 115 companies as of today and over 1,500 developers that have made active code contributions to the project. So we're seeing a lot of adoption. So what I wanted to do is share with you some thoughts about OpenStack in 2015. Because I think this is an important project. This was the subject of my keynote yesterday in Boston. And some of this was covered. Not all of it's been covered. We haven't released this yet. So this is an opportunity for all of you who couldn't be in Boston to kind of hear about how we're thinking about the project and the project roadmap over the next few years. So first of all, you want to think about what the world might look like in 2015. What do we want the world to look like in 2015 from an IT perspective? Because what's shaping up now is a bunch of big companies like Amazon and Oracle and companies like VMware that compete with them are creating proprietary ecosystems of private and public cloud platforms. And one of the challenges of that is that it doesn't give a lot of companies and standards bodies and the academic community an opportunity to influence how that unfolds. This is kind of the opposite of the internet, if you will. And I think the internet's a great model for innovation because we saw everywhere standards provided a platform for people to plug in and build great products and build great services, HTTP, HTML. There was a lot of innovation. Wherever there were no standards, where proprietary companies dominated browsers or whatever, operating systems, it was very difficult for anyone to compete and innovate. And so I think this is actually very important, and I think the reason why is if you start to look into the future and you look at what does a company do with IT? What does a company want to do with IT? I can tell you, I've started 3 companies, and until Nebula, we always built infrastructure. And every company always bought large enterprise databases and enterprise ERP systems and accounting systems. Mark Andreessen recently said that the clock is ticking on a few of these vendors because none of the companies they funded, even after they've gotten larger, have deployed any of these traditional enterprise infrastructure software platforms. And the challenge is you really don't want to run infrastructure that you don't have to run, because this stuff is getting more and more and more complex. And most companies today don't think twice about using Salesforce for their CRM system. It's difficult not to. It's a great platform. And we looked at everything out there and really didn't want to pay what they charge for the thing, but ultimately concluded that the productivity of the people doing that kind of thing is worth what they're charging for it. And they charge a premium for it. So the challenge is, as a company, you're going to start to look very closely at what you want to build out and run yourself and what you just use in the cloud. People are looking at doing email in the cloud. People are looking at doing a lot of things in the cloud. And so I think every company will start to shed all of its infrastructure, and new companies will never even accrete any of these barnacles. And they will focus on the thing that matters to them, the thing that makes them unique in the world. So if you're a biotech company, it's the infrastructure you use in your bioinformatics efforts to do protein folding or to do gene sequencing data reduction. If you're an energy company, it's the algorithms and the data that you use to do fundamental energy research or energy prospecting. And that will become what defines them. right? It's what you consume versus what you provide in terms of IT services. And if you look at this from a business, like a Peter Drucker analysis, the most efficient companies will most rapidly evolve to consuming things that are non-critical to them, and then they'll have the best of breed services in all of these areas, and then really focusing all of their investment on becoming service providers, software or IT service providers, for all the things that make them unique and special. And those are the things that they'll protect the most, right? Those are the things that they'll value the most and will be least likely interested in putting out in the public cloud, right? So I think what will happen is the private cloud for every company on earth will become the infrastructure that they use to be a provider, and there'll be all this private cloud to private cloud, you can call it that. It becomes kind of a public cloud if everybody starts using your private cloud, right? So my only point here is that you want the same foundation. You want the same standards to provide workload interoperability and portability and management interoperability to kind of underpin all this. It becomes kind of like HTTP. So if you're talking about EC2 or S3, you're talking about standards that you use to store and retrieve objects, to invoke running instances of operating systems so that you can process workloads. When you start to think about how we store data, how we represent data, how we replicate data, how we represent the combination of systems, networks, and storage topologies, and represent those as logical entities that you can invoke in different places. Those things become extremely important in a world where that's the fabric, that's the foundation that everything operates. So what does OpenStack mean to that? I think that OpenStack today has started to really build a strong foundation for compute orchestration, storage orchestration, and to a much lesser degree network orchestration, and to no degree systems orchestration. I think that in 2015, to see that future become more of a reality, we need to see a foundation that allows a standards-driven network, storage, compute, and systems foundation. So platform services and software services can be built on top of it without having to question the reliability of that storage infrastructure, the availability of that storage infrastructure. And so what we'll see is those foundational elements in OpenStack really be focused on. OpenStack has only had 4 releases. We were at the Diablo release just a few weeks ago, and this was the Essex. It's named after counties. Don't get me started. It should have been named after spacey things. But there's a county near Boston called Essex, so it's the Essex Summit. This is a 6-month release cycle, so we're kind of beginning. Diablo was the first OpenStack release that had a 6-month release cycle. We did 3-month release cycles. But if you look at how quickly this platform is evolving, the very first release was only the contribution from NASA. It was what we called Nova, which is the compute orchestration code that we built. The second release, Rackspace contributed Swift, which was their S3 simple object storage platform. The third release, we added Glance, which allowed us to serve up images to instances. And then this fourth release, we added 3 new projects, right? It was a 6-month cycle, so we, sometimes more is better, sometimes better is more. So we added a lot more to this last release. We added 3 projects. One was called Dashboard, which my new company is leading. A project called Quantum, which Cisco, Nicira, and a few other companies are leading. The Quantum project is basically a network as a service, network orchestration platform as part of our NetStack portfolio. And then a project called Keystone, which I think is the most important project. What Keystone does is it provides a common security infrastructure across all of OpenStack's components. So if you have an LDAP directory or Active Directory where you manage the identities of all of your users in your organization or in your cloud, and you have groups that you've defined, you can use your existing directory infrastructure to determine security controls across all of the different OpenStack components. And so this was implemented in Diablo, but it wasn't really well implemented. So I think that in order for OpenStack to be a better foundation for all the clouds that everybody's, and all the products everybody's building on top of it, we have to make that much more fine-grained. So role-based access control with fine-grained security controls is something that I think a lot of effort will go into over the next 6 months so that every organization can implement things differently. And I guess if you think about a way to make OpenStack fail, it's to make it only interesting to one of these groups, one of these, only make it interesting to enterprise private cloud providers, or only make it interesting to service providers, managed service providers, telcos, or only make it interesting to internet software companies that are doing software services that need something to do infrastructure orchestration. What you want to do is you want OpenStack to be the foundation for all of these things so that everybody can build and compete and innovate. And so I think the third thing we need to see continue to see is an open and pluggable architecture. One of the things that made OpenStack unique all along was that it wasn't a monolithic product. It was a pluggable architecture. And so if a large telco wanted to deploy it and they hit scalability issues with some of the networking components, there were APIs and interfaces that were defined so that you could pull that out and plug something in that scaled better. Storage is another area. We just, in the last Diablo release, inserted a new abstraction layer in the storage API so that you could pull out and plug in different storage providers. So this open and pluggable philosophy is really key to the project's success because it allows a lot of different types of customers to use OpenStack as a foundation, and it also allows a lot of different really innovative companies to go and provide value-added components that solve different problems in the ecosystem. Essentially, really what's happening here is we're reinventing the entire IT industry in a logical abstraction and in software. Everything that was once hardware is now becoming software, and then the pendulum will swing back because all that software runs on hardware, and then we're going to have to reoptimize the hardware to make everything run in this logical software paradigm again. And so that's exactly, it's fascinating to see everything completely turn on its head. But I think what this is in a way, and it was somewhat ironic that we were at the site of the Boston Tea Party yesterday as we rolled this out, and as the OpenStack project itself is being made independent from Rackspace, because this is somewhat of a revolution. In a way, what Amazon did with S3, it was a revolution. It said, look, this storage thing has gotten way too expensive and way too complicated. Let's just completely throw everything out and just get back to basics, the simple storage service. And as we start to think about representing computers logically, networks logically, storage logically, I think we need to go back and refactor everything. We have to refactor, Intel's refactoring chip design so that virtualization works better. Network companies are refactoring the way we move packets around because 4096 VLANs just isn't enough anymore, right? If you can easily have a cloud that has millions. So we have to think about new ways to segment network traffic across increasingly large topologies. We have to think about the hardware that this stuff runs on. So I think, in a nutshell, it's going to get really interesting and exciting. And if projects like OpenStack are successful, it's going to create an opportunity for a lot of innovation. If everyone ends up deploying big commercial software and hardware, then the next 25 years, I think, stand to be a lot less interesting and a lot less innovative. And so we're just one company among many that are trying to innovate on top of OpenStack, to take one small piece of that and build a great company on it. And we're really excited to see the success of the community. If anyone in the room is interested, we're kicking off the process of creating a new foundation right now. So this was just announced yesterday. The OpenStack Foundation is being spun off. We're going to be working with members of the GNOME Foundation, Apache Foundation, Mozilla Foundation, Linux Foundation. We're going to be reaching out to all the foundations that have done this before and asking them for what they did right, what they did wrong, lessons learned, because we want to create a durable foundation, and the president of Rackspace, I think, expressed it very well yesterday in our first town hall meeting, a foundation that will last through the revolution. That's the key. So we want to create a foundation with the principles and a mission that will allow it to survive for the next 25 years as we see everything we know about IT reinvented. And hopefully OpenStack will be the platform that we see all of this, happen around. So very pleased that Rackspace turned loose of the trademark and is going to literally allow a foundation to emerge with no influence from rack space. So we're super excited about that, and I'm happy to answer any questions you guys might have. I know you're trying to get out of here and get onto airplanes and everything, but I really want to thank you all for the opportunity to be here and to tell you more about what we're working on. So thank you. Okay, so we have time for a couple questions, it looks like.
Yep.
And if you guys need to leave to get onto your shuttle, that's cool.
Thanks for a great talk, and certainly for the excellent work that you've been doing under or with the OpenStack and other initiatives. Now, one of the things, because what you're talking about is we don't want our future owned by Google, we don't want it owned by Amazon or these other, Azure or whoever else has a big data vision of the future. One of the attractive aspects to Amazon, though, is it's push button easy. And one of the huge problems that I've always encountered with open source is that it doesn't do end user well. It serves the geek community brilliantly well initially, but after a period of time, once you try and mainstream it, it seems the only way it works well is if somebody duplicates it as a proprietary product. Yep. Or something changes. So have you thought about that from an OpenStack perspective, is what happens when you want to give somebody the click button access that Amazon Web Services does today?
Mm-hmm. We founded this little company. Now, I will not be self-promoting. I think there are a number of companies that, because OpenStack is an open platform, that are taking that challenge on. And I think that companies will make different decisions about how they solve that problem. But if OpenStack's the kernel, what we're going to see is distributions emerge. And there'll be distributions that are focused on service providers. There'll be distributions focused on businesses, small businesses, large enterprises. And the user experience that an employee at a big energy company has might be very different than the user experience that someone building a private cloud for their home for whatever reason, or some small business might want. I mean, if you look at the services, HP just deployed a cloud based on OpenStack. And I asked for a beta and they didn't give it to me, but then they... But if you sign up now because it's running on the Cactus release, which can't support that many users. So, so they'll run, but I'm sure they're going to fix the issues there. So I think that with these different implementations, if Amazon made a lot of assumptions about the users of that platform, and one of the guys we hired designed the user interfaces for all the Amazon Web Services. I guarantee what we're doing to focus on business enterprise deployments looks nothing like what Amazon's doing. So I think this is an opportunity for innovation. And I think I know of a number of companies that are working on solving those problems so that OpenStack becomes more consumable by non-geeks. But great question.
My name is Dave Nielsen. Most of you know me from Cloud Camp earlier. 2 quick points. Number 1, to follow up on your question, when we do all these cloud camps, that's the number 1 issue we always run into is people ask, how can I try private cloud? Do I have to go buy all the hardware to actually go and do that? That sounds pretty onerous. So I mentioned earlier that I was creating a cloud center. I had 7,500 square feet in a data center in Silicon Valley. It was just given to me. And so we're actually dedicating it specifically to make private cloud software as easy to use as public cloud. And I have like a huge community of people in Silicon Valley who've run to my events all the years who will be able to come in freely and bang away on this stuff and make it better. So that's one of the things that we're doing. But I think that one thing you should probably do is explain to folks here the difference between, say, OpenStack and other open source projects out there like Eucalyptus, because there's some similarities, but some pretty big differences. And
absolutely. I mean, I think that Eucalyptus was really first to market with an open source cloud product. I want to kind of draw some parallels, and I also want to, full disclosure, I'm really kind of an OpenStack advocate, and Eucalyptus is building something that replicates a lot of the functionality in OpenStack. So that being said, I look at the amount of developers that are making contributions to these open source projects, the community, the governance processes that establish how these projects will evolve. And what's interesting with OpenStack now is they've defined some governance constructs. If you go to openstack.org, one could legitimately argue, well, this is just rack space. A lot of these people are rack space people. Over the next year or so, that will hopefully no longer be true. Their chairman, their CEO, all of the people involved in their company have made a very clear commitment to have zero special treatment in the development of the foundation. And so I think it's the difference between the Apache projects and the Apache Foundation and a commercial company that has an open source version of their product. And I think that there will probably be types of businesses that might be able to more easily deploy something like a product than something like a platform. And I think that the real burden is on all the companies that build distributions of OpenStack and products based on OpenStack. I mean, those are the competitors of Eucalyptus, really. So I mean, if you're a business looking at whether you want your cloud powered on Eucalyptus or something based on OpenStack, I mean, right now, frankly, Eucalyptus has more features, is more mature in many ways than OpenStack. And they've been working hard on it. They got a great team. It's a great product. But it's not OpenStack either. So if you're building a cloud for the next 2, 3, 4, 5 years, you need to think about what community you want to bet on. What horse you want to get on. Because if you want if you don't want to, if you want to be part of a community where you can influence the direction of the underlying project, one of those options seems better. But again, I'm biased. So.
Yeah, and just a quick clarification. OpenStack, as far as I know, is the only one that has an incredibly open license like the Apache license.
That's
whereas
right.
all the other open source projects that are similar are all GPL or have some sort of commercially favorable license that allows the company to keep the value. This is just going right back out there, and anybody can benefit from it.
Yeah, Apache 2 and the GPL v3 stuff really makes a big difference. I mean, if you're a company, you can take OpenStack and you can say goodbye. I mean, you can fork it and you can do whatever you want with it, and you don't have to. And if you make if you make innovations based on it, you don't have to give those back. And so OpenStack truly has bet on its own future by doing that, because if it can't get governance right, if it can't sustain that momentum, it will fragment, right? And it is amazing, frankly, to see Dell and HP, Intel and AMD, a whole bunch of. What's great about, from my perspective, the OpenStack community is the diversity of it. It's not only how active it is, but how diverse it is in terms of large companies, small companies, different kinds of companies that all play into the ecosystem differently, and many competitive companies. Microsoft made a contribution to OpenStack to make Hyper-V support work through Cloud.com. So I mean, there's a lot of diversity there. Cool. Yep. Oops. Actually, one in the back here. Sorry.
Hey, Chris. I know you actively avoided plugging what you're doing now, but I think it's probably worth at least telling the audience a little bit. I think it's worth at least telling the audience a little bit about what you're working on with Nebula and how that steps things forward. I think it's quite interesting.
I'll try to answer that in just 1 or 2 sentences. As the co-founder of the project and as a company that has a lot of the engineering talent that's making contributions to the projects, we believe that it's a kernel, and there need to be some companies that step up and do distributions. And what we want to do is make it easy for businesses to deploy this thing. And so we want an Amazon behind your firewall-like experience. And what we've done is created an appliance that includes a 48-port 10 gigabit switch and all of the OpenStack services running in a highly available, highly fault-tolerant configuration. So you plug a box in, and then you can buy whatever commodity servers you want, a whole cabinet full of Dell or HP, or we have Open Compute servers from Facebook. We power them up and spec them and turn them into computer storage nodes. And so the idea is a consumer electronics device experience where you just plug this thing in, turn it on, and then you get EC2 and S3 APIs. So you don't have to have any. I could install it. That's the goal. And I just, I learn a lot from these guys, but I don't know how all this stuff works. So, yeah.
same as
Okay. Yeah. Cool.
Thanks, Chris. I'm going to take you off the detail of OpenStack for a moment and ask about innovation support. You mentioned earlier that you thought that executive support was really helpful when you were doing disruptive stuff, but to some extent, by definition, disruptive technology changes often do go against the establishment. Any words of advice on how to get the balance between encouraging innovation from our political masters and government versus how to get that amazing culture that you got in the Valley on jumping from one thing to the next?
I mean, I think that you need to have an executive that is willing to take a risk, and to do it right, they need to kind of spread the risk around. I mean, I think where I've seen this work, and I've been inside NASA for 5 years, it's when some executive has taken a risk on someone. And the director of Ames, Pete Worden, came in and took a risk on me. And if he had not done that, then I wouldn't have stirred the pot so much and done this other stuff. He also brought in about 10 other people that launched a small satellite program. Also unpopular to people that make what we call Battlestar Galactica satellites. Why spend $1 billion when you can spend a few million on a satellite? So and I think that if you don't have someone that takes that risk on the kind of people down in the organization that are able to technically deliver, nothing will happen. And so the recipe, I think, is executive support that's bulletproof, that provides air cover and completely protects you with their own jobs, right? And hiring the most brilliant people. I mean, Pete brought in guys from Caltech that were doing microwave and laser-based propulsion systems, and that's very disruptive to ATK and Lockheed and guys that make chemical rockets. Rocket technology hasn't evolved since the early part of the century, last century, and so in order to see something really interesting happen, you've got to bring really smart people together, and then you've just got to protect them because it's going to be very unpopular. Everyone will attack them. And so that's what I've seen work.
Hi, I'm not so familiar with the OpenStack and the APIs there. Yep. I tried to find some, but obviously I have to look a little bit more. It seems for me you're focusing more on infrastructure as a service. Is this correct?
That is correct.
And do you have any plans, or do you see any way to go to like platform as a service, which does have some implication also? I mean, when we commit to certain platforms, we're also kind of stuck, right? Even if we can then choose where we run our stuff.
I think the community has not made that decision yet. There are some incubator projects who have that goal. There's a project called Danabi, which is kind of an orchestration project, but it's an incubator project in OpenStack. So I think what OpenStack evolves into is a question for the community and the foundation. Today, if you look at what the community of people inside OpenStack have decided, yes, they've only decided that it's infrastructure as a service. And if you believe that it should be more, come join the debate because it's a very vibrant debate.